benefits and challenges of simulation, powered by Altium Designer's in-design capabilities, and we are going to show you the how we can perform the simulation inside the Altium Designer, and we are going to have a Q&A at the end of the demo. Yes, if you talk about the benefits and challenges of simulation. Simulation allows you to evaluate or even analyze the designs under a wide range of conditions that would be difficult to duplicate in a lab environment. You can simulate using architectural blocks as shown and use the same tools and environment as a design move towards a more granular level of implementation. Monte Carlo analysis allows you to gain visibility into worst case component variation scenarios and provides a means to improve yield, reliability, and quality. The easy what if analysis allows you to insert component substitutes into existing designs to improve an easy level of pre-qualification as substitutions are considered. Simulation provides an extra level of design due diligence that can reduce the number of hardware prototypes that will be required during the design cycle and allows you to complete projects sooner and at a lesser cost. However, these benefits are not absent their challenges. A key among the challenge is the fact that many simulation environments exist outside of the design context and require the learning of a new UI and having little integration with other design domains such as component selection, schematic design, and PCB design. If one is not careful, the time required to achieve reliable simulation results can be a detour away from the design rather than a means to accelerate design. Semiconductor vendors support for device models span a range of model formats, and support for these formats is essential to enabling timely simulation. A non-integrated environment can also make project-level data management more complex, requiring users to either forego or implement their own version control solution. Sharing and collaboration can also be a challenge when the simulation capabilities is not built into the schematic design environment. It is worth nothing that before you can be using the simulation capabilities in Altium Designer, you need to have it installed. This can be done during the initial install process or afterwards in the extension update section. We can install the simulation extension, which is a part of the Altium Designer package. As you can see in the screenshots, we can able to install during the installation process by checking this Mickey simulation. If not, by this extension updates panel where you can able to install the Mickey simulation so that we can able to perform the simulation inside the Altium Designer. Now, I would like to introduce Altium simulation capabilities. Simulation is available directly within the design context of schematic and is facilitated through with the guidance of the simulation dashboard. The dashboard provides a single panel view to assure all prerequisites to simulate such as models, signal sources, and analysis setup are in place before execution. If a problem is identified, the dashboard provides links to ease the correction. Altium provides a set of generic electronic components and function blocks with models ready to simulate. These provide designs with a rapid way to try out different approaches to circuit design. In this slide, I would introduce, we have included a few analog and digital blocks, an amplifier, AC motor, voltage controller switch, and a Jacob flip-flop. As I have mentioned earlier, model support is a key, and Altium Simulation Engine supports analog PSpice and LTSpice models. This includes PSpice.lib files with multi-model definitions. This opens the door to a wide range of device support. Altium allows designers to access models anywhere from a managed server, local file system, generic models, and directly from part listing within the manufacturing parts expand. This opens the door to the rapid creation of components with full parametric data that not only have the symbol, footprint, 3D models, but also a proper simulation model, all with Altium single clicks components acquisition process facilitated by octopart. Simulation is a part of Altium Design project structure. We see here in the project panel that the models and simulation specific parts of the design are included with the other designs and PCB assets. The optimizes organization and allows you to extend the built-in version control capabilities of Altium 65 to simulate the domain. The waveform display is treated as a separate tab in the same unified project, just like schematic, PCB, or active BOM editors. You can tile views, probe across schematics, and perform cursor-based measurements of waveform results as shown here. Now let us see how we can perform a simulation, how we can access the simulation dashboard, how we can see the cursor-based waveform analysis inside the Altium Designer. Just have a look. Let us jump into the Altium Designer. The latest version of Altium Designer is 22.5.1. As we discussed in the previous slide, during the installation process, we can enable that under platform extensions, which is simulation. If in case once you open the simulation, if you have not finding this option when you open a schematic to simulate, then it means the simulation has extension has not got installed. To install after the installation has happened, go to this top right corner, left click on this and go to extension and updates. Under installed, you'll be seeing here up not go to purchased and you will be seeing a download CL. Just click on the download and you can able to once software is installed, just restart the Altium Designer so that you can able to access the same inside the Altium Designer. Okay, this once that after restarting the computer, just open a schematic, then you will easily find this option called simulate, which will allows you to perform the simulation on the schematic design. Now let us have a look at the generic spice models which are available as a part of the simulation. Now just have a look where you can access. You all know in the Altium Designer we have a components panel available. Just go to panels components. If you go to the drop down, you can see here simulation generic components are shown here. If you click on this simulation generic components, there are the generic model files available, generic components with the model files available, where you can able to use it to perform the simulation. And also we have a support for simulation source files where you can able to add the simulation sources, voltage sources from the location where the Altium is installed. Let me go to the path. Yes, if you go here, Altium library, if you go to simulation, you can see we have got different simulation sources, simulations, piecewise functions, math functions. Just select all, and just click open and just close it. From drop down, you can able to see all the simulation special functions, voltage source, V pulse, all this you can able to add it to your design. You can perform simulation. Okay, this you can able to add the your simulation source files or the library files as we discussed the pspice .library files we have. You can directly add it to the components panel and you can reuse it here to perform the simulation. And also we Altium support importing LT-spice files where we can able to import and you can perform the further steps inside the Altium Designer. Yes, now we are having a example circuit bandpass filter. Now let us see how we can perform a simulation on this circuit by using the Altium Designer simulation capabilities. As we have explained, we have the extension got installed inside the Altium. Just go to the simulation, then you have a simulation dashboard. The simulation dashboard helps you to perform the analysis. Here we can see we have two options available, which stands if we have a group of sheets, like multiple sheets are a part of the project. You want to perform simulation on a particular sheet, or if you want to perform the simulation on the project, you can able to select from the drop down. This is the one new feature and which is good feature, I believe, so that you can able to perform the simulation on individual circuits as well as the whole process. And next step, we need to do the verification. This verification checks the ERC, ethical rule check, followed by are there any model file issues with the component it will verify. Now let us do the verification. When I say start verification, the first it has checked the ERC, electrical rule check. You can see here it's been qualified. And then we have some issues with the component simulation model files. As we have explained during the presentation, we need to have the model files to be required to perform the simulation. Many of the component vendors will be providing the SPICE model. If not, we have a generic simulation models are available. You can use that, which is equivalent to your requirement, then you can perform simulation. Here, when you say verification, it is asking that we have simulation models can be auto assigned to the RLC, register inductive capacitor. Yes, if you want to assign, yes, you want to assign it. But we have an active component operation amplifier, which we need to add it manually, as we don't have an option to add for the active components. Yes, just add the model. We have a four options. One is local. You can able to browse from your local computer. You can able to add it, and from the library, you can just browse it, and you can able to see if the component is available in the part of the library. And also we have other options from from server. It means if your model file is situated located in your local server or the connected server, you can able to access, or you can able to access from the Octopod. Now I have already a component added to the project, which will be shown under library. Just click on browse. You can see we have got the UA741 IC model file, and you could see we have got the simulation generic components also shown here. If the component which you are looking for is meets your generic component, so you can select and you can perform it, as we have the right model file, subcircuit file, so that we can use it to perform the simulation. Now let us say OK. Once you say OK, it is showing the path and what is the model type. And the next important thing we have to do is schematic pin mapping with reference to model pin. If you want to read the model file, just click on this model file window. You can see this is the model file, which will help us to perform the simulation. Now you can see here we have got the pin mapping with respect to the model, and this is the pin mapping with respect to schematic. Here in schematic, the first one is offset null. Here in the model file, the first one is non-inverting. That is make it as a not connected, whereas it's not there in the model file. Second pin is inverting. That's fine. Third pin is non-inverting. That is make here in the first pin as per the model. And followed by we have fourth pin is negative voltage, yes, 4 4. And we don't have offset null, let us make not connected. And we have sixth pin schematic is the output, and in the model we have fifth pin is the output, and then seventh pin is the positive voltage, and here we need to have the third pin is the positive voltage. This is very important. We have to map the schematic pin with respect to the model. Then once it's been completed, let us click OK. Now see the simulation, it's been passed, and we are good to move towards the next step, that is called preparation. And the preparation, we could see we have identified three voltage sources. V1 as it is an operation amplifier, which requires positive and negative voltage. If you want to edit the voltage values, just double click and it will open the properties panel. You can able to see what is the source and what is the your DC magnitude for the positive and negative. We can able to get the same. And for the pulse, we have given AC magnitude as 1 volt peak to peak for the pulse. Now once it is completed, next we have option to add the voltage current probes from the here. And then next we have got the analysis setup. Then the analysis setup, we have got operating point, DC sweep, transient, and AC sweep analysis we have. Now let us perform transient analysis, and let us have the expressions for V input and V output. We can have the expressions. Let me add it. Yes, V out I want to have. If you want to have any special functions, you can be able to pick those functions from here. Just and also have measurement functions also available. We can able to do the measurements. Just click OK. I want to have see the voltage between V input and V output. I want to see what is the output expressions. And let us click on run the analysis. Once we run the analysis, let's see the message panel has been opened. Let me make the protest panel a little small so that it will be Now you can see this is the we input where we have given 1 volt peak to peak pulse signal, and this is the output where you can see here. If you want, you can have cursors and be added to this waveform. You can able to see what is the differences between these waveform with respect to the voltage and time. You can have the same, while in this sim data you can able to have the measurements the data analyzed. Okay, and also we have in Altium Designer multi-colored analysis where you can able to perform the analysis with the different values of the components, how your circuit behaves with the different values of the components. For that, we can just analyze multi-colored analysis. Just click on the settings, and I can able to. We have got sensitivity analysis as well in the upcoming next webinar, which is going to happen the last Friday of this month, which we are going to discuss about the more detail about the sensitivity analysis. Now let us see how we can perform the multi-colored analysis with different values of the passive components, how your circuit behaves. You can able to perform and you can able to see what the number of pins you want to have. You can able to select and just click on OK, and then perform the transient analysis. You can see I got 10 waveforms we are given. You can see with respect to these values of resistors and capacitors and voltage sources, what is your expression with respect to these values, what will be their output. You can able to see with different values, and you can able to adopt one which is suiting your requirement, and you can able to do the changes in the circuit, and you can proceed further. Okay, this is how you can able to perform the motor current analysis inside the Altium Designer. And also we have a you know another option where you can able to perform all the simulations at a time. If you click on run simulation, it will perform all the simulations at a time. You can see here operating point analysis, and you can see the DC sweep and the transient analysis and the AC sweep analysis of your design at a single click. And then if you go a little bit down, you can able to see all the results of your design over here. This is how you can able to perform a multi-colored analysis and the transient analysis inside the Altium Designer. Now let us see how we can perform a board plot, how we can do the board plot analysis inside the Altium Designer. For this, I just have an example called active low pass filter. This is my circuit. By this circuit, I want to perform the board plot analysis. To do so, we have to have the same step. First, you need to start the verification, followed by preparation, and analysis setup. For the board plot analysis, we are going to perform the FCSP, that means frequency analysis of our circuit. Now we need to enter what is the start frequency. We need to have the start frequencies 10 and end frequencies 100K. And what is the resolution of your output? You can able to mention what is the value you want. It's in decade, the resolution points per decade. And then followed by you can able to mention what is your output expression. You can able to perform. You can able to select here. If you want to have voltages, suppose V1 create, and then you can just perform the AC sweep analysis. But here if something went wrong, let us want to run with this. Yes, I think this is the how security resolution we have given 1.5 decade. That is why the graph is showing the finest form. To have the smooth curve of the responses, now let us change this points per decade resolution to 1000 and perform the analysis. You can see we have got some smoother response of the waveform with respect to the frequency of 100K. Now let us have a few expressions to perform this analysis. Uh, Now let us go to simulation dashboard. Let us add expression. I want to have my cutoff frequency, and it should be magnitude in dB, and followed by I want to have measurements for the cutoff high. Let us make it for cutoff high. Okay. Here we are going to have the gain, and also we are going to have our cutoff frequency. It is perform the analysis. Here the points per decimal, let us make 1000. Okay, so you get a better output. Now click on run. These are gain. You need to see to get the cutoff thing. Just go to sim data. You can also add the P in and P out to the our waveforms, and to have to see the cutoff frequency, just go to the measurement, just double click and click on the show on card. This is the we have got the two cursors where you can able to help you to see the cutoff frequency. I think let me I did something wrong. Let me again perform same. Yes, this one. You can see we have got the cursors A and B, which help you to see the data, minimum and maximum and mean frequency. And if you go to the general, you can able to see that here the difference between the A to B, B to A, what is the minimum of A to B, maximum of A to B, you can able to see here. This is how you can able to perform and see the board pattern analysis inside the Altium. I'm not going to talk much about this now, as we are going to discuss much detailed in our next webinar simulation capabilities in the next upcoming webinar on the last Friday of this month. Please do join to know the in-depth capabilities of simulation inside the Altium Designer. This is all about how we can perform simulation inside the Altium Designer, like verify as we design with the Altium Designer's in-schematic simulation capabilities. Now we are